Ever wonder how AI deciphers that Apple and Steve Jobs are linked, or how your search engine connects Einstein to relativity? It's all about relation extraction, a cornerstone of making sense of the chaotic, unstructured text we encounter daily. But here's the challenge. Training AI to spot these connections traditionally requires massive labeled datasets, which are time-consuming and costly to create. Enter a breakthrough approach called SCoRE, which is redefining how machines understand relationships in text. Let's dive into the science behind it and why it matters. The core problem. Real-world text is a minefield of ambiguity. Take the sentence, Marie Curie discovered radium. A human sees a clear relationship, but for AI, it's a puzzle. Traditional methods rely on manually labeled examples, like marking, discovered, as the relation between Marie Curie and radium. But this approach is brittle. What if the same sentence also mentions her birthplace or nationality? That's multi-label relation extraction, identifying all relationships in a single sentence. Traditional models struggle here, often missing subtle or overlapping connections. This is where SCoRE shines. It leverages pre-trained language models, like BERT, to convert sentences into dense vector representations, mathematical embeddings that capture semantic meaning. But SCoRE doesn't stop there. It clusters these vectors in a high-dimensional space, grouping similar relationships like books on the same topic in a library. When predicting a relationship, SCoRE uses a Bayesian KNN framework. It identifies the most similar sentences in its training data and aggregates their votes to determine the most likely answer. Think of it as a democratic process, letting past examples guide the decision, rather than relying on a single, rigid rule. But how does SCoRE handle the noise in real-world data? The researchers tested it on Wiki20D, a dataset derived from knowledge graphs, which mimics real-world complexity by using only structured annotations. The results? SCoRE matched or exceeded state-of-the-art models, while using significantly less computational power. And here's a critical insight. Adding complex tweaks actually hurt performance. Simplicity, it turns out, is the secret sauce. Yet SCoRE is just one piece of the puzzle. Researchers are also tackling relation extraction through techniques like distant supervision, attention mechanisms, and knowledge graphs. Let's unpack these. Imagine training a model without manually labeling data. Distant supervision uses existing knowledge bases, like Wikipedia, to automatically label training examples. For instance, if a knowledge graph states Paris is the birthplace of Victor Hugo, the model assumes any sentence mentioning both Paris and Victor Hugo contains the born in relationship. But this approach isn't perfect. Knowledge bases are incomplete or noisy, leading to inaccuracies. To combat this, models use attention mechanisms, a way to focus on the most relevant parts of a sentence. When parsing Apple was founded by Steve Jobs in 1976, the model zeroes in on founded by and Steve Jobs, ignoring extraneous details like the year. This selective focus improves accuracy, especially in complex sentences. Another technique is contrastive learning, which trains models to distinguish correct relationships from incorrect ones. It's like teaching a dog to fetch only the red ball by showing it pairs of similar items and rewarding the right choice. By comparing positive and negative examples, models become more robust to noisy data. Finally, knowledge graphs, structured webs of real-world facts, act as a sanity check. If a model guesses Einstein was born in Paris, the graph flags this as false. Integrating these graphs into training helps models align their predictions with established knowledge, reducing errors. Why does this matter? These innovations are making AI systems faster, smarter, and more adaptable. SCoRE's efficiency enables real-time applications, from legal document analysis to smarter chatbots. Meanwhile, techniques like attention mechanisms and knowledge graphs ensure models stay accurate even when faced with ambiguity. The next time you interact with AI, whether it's a search engine, a virtual assistant, or a news aggregator, remember, behind the scenes, breakthroughs like SCoRE and its peers are untangling the web of relationships hidden in text. The future of AI isn't just about processing data. It's about understanding the world with precision, efficiency, and a touch of elegance.